Hello, good morning. I SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, video 141. It is for BSc Part 1 Organic Chemistry, Paper 2, Unit 1. Inductive and field effects. Properties of an organic compound is influenced to a large extent by the transfer of electrons taking place in its covalent bonds. This transfer of electron may be permanent or temporary. Knowledge of transfer of electrons in the organic molecules help in understanding acidity, basicity, neutral, stability, reactivity, etc. Inductive effect. This is a permanent effect operating in polar covalent bonds. The induction of a permanent dipole in a covalent bond bearing two unlike atoms of different electronegativities is referred to as the inductive effect. For example, here carbon and hydrogen. This also having different electronegativity. So it is a polarity. Here carbon-carbon, there is covalent bond between them, but there is no polarity. If halogen is attached, then there is large polarity. Means carbon is positive charge and halogen is negative charge. See here the polarity difference. Minus I and plus I. Here, minus I effect is increasing from phenyl to nitro group. See here the phenyl, methoxy, halogens, because electronegativity is increasing, carboxylic, cyanide, nitro. Here plus I effect is in increasing order from hydrogen to isobutyl. So it depends on the polarity of the covalent bond. The phenomenon of inductive effect is very important in organic chemistry as it helpful in explaining a number of facts. Reactivity of alkyl halides. See here, this is a alkyl halide, methyl chloride. Methyl group is a positive charge and chloride is negative. So this positive side for the attack of electron-rich reagent. Dipole moment. Due to the electronegative difference of the atom, dipole moment is also different. Here it is in increasing, inductive effect is increasing, dipole moment is also increasing. Here one more factor, size of the atom is also responsible. Size of atom is here iodine having higher, so electronegative difference will be reduced. Relative acid strength of chloroacetic acids and acetic acid. Here, due to the presence of halogen, it will pull electrons from the molecule. So, it's due to this proton is more isolated from the molecule. So its acidic nature is increasing. Here it is acetic acid and here chloroacetic acid. Chloroacetic acid is more acidic than acetic acid. And here it is increasing. If suppose two chlorine groups are there, dichloroacetic acid, its acidic nature is more increasing. If it is trichloroacetic acid, it is more acidic than compared to chloroacetic acid. The decreasing order of acid strength. See here, acetic acid is less acidic compared to trichloroacetic acid. Relative acid strength of formic acid and acetic acid. See here. Formic acid. This acetic acid, it contains methyl group. It is a electron donating, electron releasing group. So polarity between this oxygen hydrogen is decreasing. So its acidic nature is higher. Whereas here in formic acid, it does not have any electron releasing group. So this polarity will be remain as it is. It's higher compared to acetic acid. So it is a more acidic. Formic acid is more acidic compared to acetic acid. Or we can say acetic acid is weaker acid compared to formic acid. See, methyl group has an electron releasing effect or plus I inductive effect. Therefore, acetic acid is weaker and then weaker acid than formic acid. Relative acid strength of halogen acid. See here, it is a fluorine, chlorine, bromine, iodine. Since the inductive effect is decreasing with increase in the distance of halogen atom from the carbonic group, the strength of acid is proportionally decreased. See here. So fluoroacetic acid is more acidic compared to hydroacetic acid. Here, alpha chlorobutyric acid, it is more acidic compared to beta, compared to gamma, and compared to N-butyric acid. Reactivity towards electrophilic substitution in aromatic compounds. See here, toluene, high electron density, more reactive compared to benzene. Toluene is more reactive compared to benzene because it having methyl group, so it will give electrons to benzene ring. Whereas if nitro group is attached, it will withdraw electrons from the benzene ring, so electron density is less, so it is a less reactive compared to benzene. The relative acid strength of water, phenol, and methyl alcohol. See here, hydroxy group minus I effect, phenol, water, and methyl alcohol. Methyl alcohol having plus I effect. So relative acid strength of water, phenol, and this. So here phenol is more acidic compared to water compared to methyl alcohol. Strength of base. A compound is said to be basic in nature if it is capable of accepting a proton. See here. The decreasing order of base strength in alcohols is due to plus I effect of alkyl groups. So it is more basic compared to this, compared to methyl. Greater the tendency to donate electron pair for coordination with proton, more is the basic nature. That is more the negative charge on nitrogen atom due to plus I effect of alkyl group. Higher is the basic strength, Thus, the basic nature decreases in the order. See here, relative basic strength of this is more basic compared to this one. Relative stabilities of carbon cation. This tertiary carbocation is more stable compared to secondary than methyl carbocation. Reactivity of carbonic compounds in nucleophilic addition reactions. See here, decreasing order of nucleophilic addition. Plus I group increases the electron density on carbonyl carbon. This therefore decreases the rate of nucleophilic addition. On the other hand, if electron withdrawing minus I effect is there, it will decreases the electron density on carbonyl carbon and thereby increases the rate of nucleophilic addition. Inductive effect is also dependent on the difference in the state of hybridization of the atoms linked by covalent bond. Relative acidity of hydrocarbons may be given as this is a here sp hybridization. It is a sp2. In ethene, it is a sp2. In ethane, it is sp3. Relative basicity of corresponding carbon anion is as under. This is a ethyl carbon anion, ethylene, ethine carbon anion. So, basicity of acrylic acid is it is more acidic compared to propionic acid. Field effect. When the inductive effect is transmitted through space or solvent molecules, it is known as field effect. See here. Here two chloroatom. They are here in cis, where these two chloroatom are away from the trans. So it is more acidic compared to this molecule. This is less acidic. So field effect is also responsible on the acidic nature of the molecule. Electromagnetic effect. It is temporary effect in unsaturated compounds. It involves the complete transfer of said pair of pi electrons of a multiple bond to the more electronegative atom of the bonded atoms due to the requirement of an attacking reagent is called electromagnetic effect. See here, this is a carbonyl and it is due to the polarity, it will be polarized and it will give plus E effect, electromagnetic effect. Suppose propene is there, so here will transfer electrons, and when proton is added, it will be give secondary carbocation. When the transfer of electrons takes place away from the attacking reagent, the effect is called minus E effect, minus electromagnetic effect. See here, this sign, right? When it is added, then it will form and when I and E effect occur together in a molecule, then E effect generally dominates over I applications. Due to the electron transfer, it will do various types of reaction: electrophilic addition reaction, nucleophilic addition reaction, electrophilic substitution reaction. So this is about the field effect, electromagnetic effect, inductive effect. So thank you very much for today's lecture.